Links to everything will be in the description below. The first step we need to do to set up our patrol state is to set up an area collider. All this is an empty game object with the box collider on it, and it is set to be a trigger. This box is going to represent the area that we can patrol in. So the script's going to choose a random point in this area and move our guy to it. The first thing we need to do code-wise is open up our melee enemy script and add this action. We'll go over actions in the events video. I'm going to post in the top right. Essentially, it's a way to have one script shout out to the void, hey, I did this thing, and then have another script listening for it. When they hear, oh, someone did this thing, I'm going to do my thing. So the two scripts do not need to have a direct reference to each other. So right here, we've got an action. It takes in a float, and we're going to call it onMoveCall. Then in our move function, we need to say this code. If our onMoveCall does not equal null, all this means is someone listening? So as long as someone out there is listening, we are going to call that function, giving it our speed. We are getting our speed variable from our inherited enemies class. Now we need to set up a script that is listening for it. We're going to call this script melee move. I'm going to just put it in my enemy script. Once that script has loaded, we are going to need to immediately make a reference to our level collider. Additionally, we will need a reference to the random point that we want to generate within this collider. I'm going to make that by just setting up a private vector2 random point. In our start function, we want to get a random point as well as subscribe to our event. So right now we're going to have two red things. That's because we haven't created either of these functions. But this right here is going to look for a melee enemy component on our same game object, because melee move is going to be on the same enemy as our melee enemy script. And we are going to assign our move toward function to that call. So what that means is when we shout out here that we are wanting to move and giving it a speed, this function is going to be the function that's listening for it. Let us set up our safety check. So anytime you subscribe to something using an event or an action, you want to also have an onDestroy clause. This prevents memory leaks from happening. What this says is that anytime our enemy would be destroyed, we unsubscribe from that event. If you do not unsubscribe, the computer might be fooled into thinking that there's something listening for it when there in fact is not, and it will add to inefficiencies in your program. The term for this is memory leak. Let's go over our move toward function first. So this function is going to take in our float speed, and we are going to, if we have a random point to move towards, we're going to move towards it. So the first thing we do in this function, after we make sure that a random point is not equal to null, is we draw a line from our position to the random point. This is just a debug line so the developer can see where we're moving towards. Then here we are rotating to the direction we're moving in. So we make a new float, or call it angle in radians, that's why it's called angle rad, and we get the tangent of a random point's y minus our transform's y. So this is where we want to go y minus where we are's y. Then over here we do the same thing on the x. And this will give us an angle, which we then convert to degrees from radians in this line here, and then we rotate ourselves along the x-axis to that angle. This minus 90 part might change. This is completely dependent on how your art is set up. Experiment with different values here. Most likely you will want to do values in increments of 90, so maybe like positive 90, 0, 180, negative 90, so on and so forth. Then our next line is we move towards that location using vector2.moveTowards. We take our position, that's where we're starting off at, random points where we want to go. We're going there at a speed of rate times time.delta time. All the time.delta time does is makes it frame rate independent. Then we need to find out if we need to find a new random point. So this says if the distance between us and the point we want to go to is less than 0.1f in our case. I'm going to just change it to 0.2f real quick. If that is the case, so if we're almost there, we're going to go find a new point. The reason why I changed it was just because I want it to be a little bit less sensitive, so we don't have to be exactly on the point. Then we're going to go find a new random point. Speaking of, we need to add in that function. And that function looks like this. This function has a return type of vector2. We start off by creating a new vector2 point, and it's going to be a random number between our minimum x and our maximum x. The level collider.bounds.min and the level collider.bounds.max refer to this box. So the minimum in the x is going to be all the way to the left. The maximum in the x is going to be all the way to the right. Same thing for the y, except it's up and down. So this is saying we're going to choose a random point between all the way to the left of our box and all the way to the right of our box. And we're going to do the same thing for the y. So this chooses a random point within our box. Then we do, if our point does not equal level collider.closest point, feeding it our point. What this means is if we are on the edge, then we want to find a new point. Then we return whatever our point is. Our last bit is this onDestroy function. We've already talked about it. So the way this script works is at the beginning, we're going to choose a random point in our collider. So it's going to choose a random point between the bounds of our box. If that random point is ever on the edge of the box, we're going to go fish again and get another point in the box until it finds a point that is satisfactory. Then we will return that point, go to our move towards function, and rotate to face that point, and then move towards that point. If we are ever almost at our point, we're going to go find another point. So we're going to save this script. To set up in Unity, all we have to do is attach it to our enemy. So I'm going to open up our prefab. I'm going to add our melee move to it. It's going to ask for a level collider 2D. So right now, we can manually drag it in to test it. The way to set it up in code, automatically find our level collider. All we have to do is this line. So we're going to set our level collider in our start function equal to GameObject.findObject with tag level get component collider 2D. So it's going to find the object with the tag level, and then it is going to assign its collider to our level collider variable. I just have to set up that tag in Unity. So I'm going to go to my tags here. I'm going to click add tag. I'm going to add a tag, and I'm going to name it level. Then I'm going to select my area collider and select level from the list. Now I'm going to hit play, and you can see we are now patrolling. On the scene view, you can see our debug line indicating which spot we're moving towards. And as you can see, you do not see that debug line in our game view. I hope you found this interesting. Please hit the like and subscribe buttons. Comment below if you have any questions. Next time we are going to go into our attack function. See you guys in the next one.